Simple words, it was an interstellar mission. There are millions of solar systems in our Milky Way galaxy. The space between these solar systems is known as interstellar space. Till date, NASA has launched only 5 interstellar spacecrafts. They were the Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. And only 2 of these 5 have been able to reach interstellar space because it takes an extremely long time to reach the interstellar space beyond our solar system. The 2 that have reached this are very special. Voyager 1 and Voyager 2. They went around exploring our solar system, giving in amazing photos of Jupiter, Saturn, Uranus, and Neptune. Till date, Voyager 2 is the only spacecraft to have gone near Uranus and Neptune. And the Voyager 1's journey has been so long that it has officially become the man-made object that went farthest from the Earth. As of October 2024, it is 24.7 billion kilometers away from the Earth. But the most interesting part about these 2 Voyagers is that they are carrying messages for aliens. That is now traveling through space. These messages were sent with the hope that we might meet aliens someday, and through these messages we can tell them something about us. We step out of our solar system, into the others. What is hidden in these messages? What message does NASA want to convey to aliens on behalf of humankind? Let's know the story of the Voyager missions in this video. Friends, in 1965, an engineer working at NASA noticed that the last 4 planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, would be in a unique geometric arrangement during the late 1970s. An unique arrangement, which occurs only once every 175 years. This arrangement meant that a spacecraft could be sent which could take advantage of the gravitational force of these 4 planets and pass near these 4 planets using relatively little fuel and time. This principle is called gravity assist. Using the mass of a planet or an object in space to change its speed and trajectory. Based on this principle, NASA made plans for its Voyager 1 and Voyager 2 missions. And this is why the year 1977 was chosen to launch these 2 spacecraft. According to the mission, Voyager 1 had to fly by Jupiter and Saturn, especially focusing on Saturn's moon, Titan. And Voyager 2 had to pass by Jupiter, Saturn, Uranus, and Neptune. The design of both the spacecraft were quite similar. Both were powered by 3 radioisotope thermoelectric generators. They did not have solar panels. Because after crossing Mars and Jupiter, solar energy becomes useless to a large extent. At that distance, the sun's rays do not have sufficient energy so that solar energy could be obtained from it. While their mission was to fly beyond the solar system. That's why these devices are powered by the radioactive decay of the element plutonium. When plutonium decays, heat is released. That heat can be converted into electricity. That's why it was named the radioisotope thermoelectric generator. Apart from this, both the space probes carry 10 scientific instruments. A 2-camera imaging system to take pictures, a spectrometer to measure the abundance of hydrogen, another spectrometer to measure the ultraviolet activity in the space, a magnetometer to measure the magnetic fields of the planets, a high-gain antenna to communicate with the Earth, and some other small instruments to measure different levels of radiation. The interesting thing is that Voyager 2 was launched before Voyager 1. Voyager 2 was launched on the 20th of August 1977. And 16 days later, on the 5th of September 1977, Voyager 1 was launched from NASA Kennedy Space Center. Voyager 1's route was shorter and faster than Voyager 2's. So, Voyager 1 reached Jupiter first, and in March 1979, it recorded this amazing time-lapse. This is a time-lapse made with 66 different photos. Each photo was taken after Jupiter's 1 rotation period. Jupiter's rotation takes about 10 hours. This was the first time we could see such clear-cut photos of Jupiter and its moons. And this is when we discovered Jupiter's rings. Many people think that only Saturn has rings around it. But there are rings around Jupiter too. Although they are not clearly visible unless you are close to it. Jupiter, its moons, and its rings, these 3 components together are called the Jovian system. The word, Jovian, comes from the Roman god of sky and thunder, Jove. And Jove's other name is Jupiter, on which this planet was named. Now the thing is, friends, 3 other planets in our solar system are like Jupiter. Saturn, Uranus, and Neptune. There are rings around all these planets, as well as multiple moons. These are gas giants. This is why these 4 planets are collectively called the Jovian planets. Jupiter-like planets. During the exploration of this Jovian system, Voyager 1 discovered the ongoing volcanic activity of Jupiter's moon Io. This was the first time humans had seen active volcanoes on another planet. Before Voyager 1 reached Jupiter, we thought that Jupiter had 13 moons. But once Voyager 1 reached there, we found that there are 2 more moons. A few months later, on the 9th of July 1979, Voyager 2 reached Jupiter, and it could get even closer to Jupiter. Once it got closer, we discovered another moon near Jupiter. Because of the discoveries of these Voyager missions, the number of Jupiter's moons increased from 13 to 16. But do you know what, friends? We have discovered 95 different moons. That's right. 95 moons orbiting around Jupiter. About 1.5 years later, on the 12th of November 1980, Voyager 1 reached near Saturn. By this time, Voyager 1's speed had increased much more than Voyager 2's, that it took 9 more months for Voyager 2 to reach Saturn. Once it reached Saturn, Voyager 1 discovered 3 new moons: Atlas, Prometheus, and Pandora. Pandora is the same name that the alien planet in the film Avatar was called. But in reality, it is the name of one of Saturn's moons. At that time, there were about 15 known moons of Saturn. But by now, around 146 moons have been discovered. Voyager 1 has captured the photos of many moons. You can see some on the screen. Among them, perhaps the most interesting is the moon Titan. Apart from the Earth, this is the only object in our solar system where we have clear evidence of the existence of a lot of water in liquid state. This is why many science fiction movies are based on it, where Titan is shown as a place that either has aliens, or where humans can live. Titan can become our home. After crossing Saturn, the paths of Voyager 1 and Voyager 2 diverge. Voyager 2 continues towards Uranus and Neptune, and becomes the first and only man-made object to fly by near these planets. It passed by Uranus in 1986 and Neptune in 1989. And we get these marvelous photos. On the other hand, Voyager 1 changed its trajectory and left the ecliptic plane. If you don't know what an ecliptic plane is, it is an imaginary plane on which the planets of our solar system revolve around the Sun in their respective orbits. If you look at it in 3 dimensions, the plane looks like this. The orbits of the planets may differ by a few degrees, but they look almost like a flat plane. But Voyager 1 flies above and beyond this plane. Using gravity assist, Voyager 1's probe gets extremely fast. Today, it is flying across space at the speed of more than 60,000 kilometers per hour. In this diagram you can see the rough estimates of the current location of Voyager 1 and Voyager 2. On the 1st of January 1990, Voyager's interstellar mission began. The official mission was to go beyond the Sun's influence. The next month on Valentine's Day, on the 14th of February 1990, Voyager 1 took this famous photo. The pale blue dot. This photo was taken when Voyager 1 was about 6 billion kilometers away from the Earth. In it, our Earth looks like a small blue dot. From this perspective, Voyager 1's camera took a selfie of our inner solar system. A family portrait in which Venus, Earth, Jupiter, Saturn, Uranus, and Neptune can be seen together. If you are looking for Mercury and Mars, they are not visible in it because of the Sun's harsh reflection. And our poor Pluto is not considered a planet anymore, so no one cares about it. And it was too small to be visible in this photo. After taking these last few photos, Voyager 1's cameras were shut down to save power and memory. And actually, there wasn't anything of substance after this that could be seen in the darkness of space. Voyager 1 was moving straight ahead towards the darkness of interstellar space. After this, for years, there was no update from Voyager 1. In 1998, there was a minor update when it became the man-made object that went the farthest from the Earth. Then, in 2004, it was said that Voyager 1 passed the termination shock. This is a point on the edge of our solar system where the solar wind decreases suddenly. Do you know what solar wind is? These are the charged particles emitted by the Sun. They form a bubble of sorts all around the solar system. This bubble is known as heliosphere, and this heliosphere protects us from interstellar radiation. When we reach the heliopause, the outer boundary of the heliosphere, the solar winds become weaker. You can better understand it using this diagram. Closest to the Sun are all the planets. After Neptune, comes the Kuiper belt that houses many of the comets that come near Earth. I talked about this in the video on asteroids. The termination shock region begins somewhere here. After this is the heliopause boundary. After the heliopause, many diagrams show a bow wave region, before the interstellar space begins. Based on the beliefs of many scientists, until Voyager 1 actually went there. On August 25, 2012, Voyager 1 left the heliosphere and finally entered the interstellar space. Since then, the scientists' view regarding the bow shock region changed completely. Today, scientists believe that this is basically an interaction area where interstellar radiation meets solar wind. A sort of a diffusion region with no clear-cut boundary. But think about it, friends. It was only in 2012 that Voyager 1 crossed the boundary. It took 22 years for this interstellar mission to reach interstellar space. NASA took 8 months to confirm this. They double-checked and rechecked the data for many years. And finally in September 2013, they announced that a man-made thing has crossed the limits of the solar system for the first time. It is only with data science that we can make advances in the field of space exploration. But it's not limited to space exploration. Data science has now become one of the most lucrative career choices in the world. It is used in almost every industry. Automobile, finance, media, healthcare. An interesting question arises here. How did we find out that Voyager 1 crossed this boundary? Friends, we found out because of its plasma wave instruments. Between the 9th of April and the 22nd of May 2013, a powerful solar eruption was recorded by Voyager 1. Because of this eruption, the electrons near Voyager 1 began vibrating. Researchers noticed that the electron density near Voyager 1 was very high compared to the heliosphere. This tells us that it has reached interstellar space. You may be wondering how it could be possible. How can electron density be higher outside the solar system than inside the solar system? This is because in the heliopause region, there is a great dip in the solar wind. When Voyager 1 was in heliopause, the electron density was very low. And as soon as it reached the interstellar space, there was a sudden spike. The only difference is that the spike in electron density before the heliopause was due to solar wind. And the spike in electron density after the heliopause was due to interstellar wind. We could find out all of these with the help of this high-gain antenna. The photos, the findings of its instruments, the critical information of the mission, they were all being transmitted through this antenna, and were being received on Earth by NASA's 3 Deep Space Network stations. These Deep Space Network stations are absolute marvels in their own right. They are present in 3 locations all across the world: California, Madrid, and Canberra, Australia. In this animation, you can see that the 3 locations cover most of the area on Earth. If you watch my vlog channel, you might remember when we went on a tour of this Deep Space Network station in Australia. If you want to see it now, the link is in the description. When the researchers got the data, they backtracked it to calculate the exact day when Voyager 1 entered the interstellar space. And then, they confirmed that the date was the 25th of August 2012. And coincidentally, it was the same day when Neil Armstrong, the first human to set foot on the moon, passed away. Till now, we were talking about Voyager 1. But what about Voyager 2? Voyager 2 entered interstellar space 6 years later, on the 5th of November 2018. They are the only 2 space probes to have achieved this till now. And both of them are carrying messages for aliens. Now, even though both these Voyager missions have broken many records, but in terms of attempting to send messages to aliens, they weren't the first spacecraft. Before them, Pioneer 10 and Pioneer 11 tried doing this. Actually, the messages carried by the Voyagers for the aliens were sent before on Pioneers 10 and 11. The only difference is that Voyagers have used new technology and are carrying detailed messages. Pioneer plaque is a small gold anodized aluminium plate used on the Pioneers 10 and 11 spacecraft. The message written on it will tell the aliens about our planet Earth. NASA has called it a mark of man. This plate is only 15 centimeters by 23 centimeters and has 5 engraved diagrams. It has information about our location in our galaxy. The radial diagram in the middle is actually a map. On this map, the position of the Sun is shown in relation to 14 pulsars. Pulsars are degenerated stars which rotate rapidly and emit regular pulses. Basically, to understand this map, the existing intelligence level of a race should be such that they already know the basics. At the bottom of the plaque are the planets of our solar system, with the Sun on the far left, and then the planets based on their distance from the Sun. They engraved an arrow pointing to the third planet, to show the planet from where the spacecraft came. In the middle right, there's even a silhouette of the spacecraft. Additionally, you can also see the drawings of a man and a woman. Basically, it is an attempt to show how humans look like, the ones who made this spacecraft. NASA has said that this interstellar slab shows that the human race possesses a spiritual insight that takes it beyond the material problems of development. Broadly speaking, this is quite a basic sheet. Aliens won't get a vast wealth of knowledge just by decoding it. That is why the information sent on the Voyager missions were much more detailed. The messages sent with the Voyagers are actually 12-inch gold-plated copper discs and phonograph records. They carry voices as well as images. There are 2 such records carried by both Voyager 1 and Voyager 2. Let's look at them in a bit more detail. The phonograph, also known as the gramophone, looks like this. These are flat discs that can store sounds. These were very popular at one point in time, especially during the 1970s when the Voyagers were built. On these discs, there are grooves arranged in a spiral pattern. Sound waves are encoded on it. When a needle is run along these grooves, it produces vibrations, which then reaches the sound box. There it meets a membrane that starts vibrating with it, making it possible for you to hear the recorded sound waves once more. Often these sound waves are amplified using a horn to hear it loudly and clearly. Today we have turntables and record players that apply this concept. But the technology is different. Today, the vibrations produced by the needle are first converted into electrical signals and then the sound is amplified. While a phonograph doesn't do it. The records sent on the Voyagers have been named the Golden Record. The contents of this record have been divided into 4 sections. The first section is Scenes from Earth. It contains 115 images and diagrams providing information about our planet and the species on it. It includes basic mathematical, chemical, and physical definitions as well. The second section is Greetings from Earth. Greetings spoken by humans in 55 languages. It also carries printed messages by the then American President Jimmy Carter and the then Secretary General of the United Nations Kurt Waldheim. Of course, to understand these messages, the aliens would need to know English first. The third section is Music from Earth. It contains musical selections from different cultures and eras on Earth. There are 28 audio recordings of Eastern and Western classical music, including an Indian song based on Rag Bhairavi, Jat Kahan Ho, sung by Sir Shri Kesarbai Kirkar. The fourth section is Sounds of Earth, where the natural sounds from Earth can be heard. It contains 21 audio recordings of human activities, machines, and natural phenomena. Like this. Obviously, if aliens are to hear these sounds, they would need to know how to operate this phonograph. And so NASA's scientists added the instructions in the box. The good news is that these instructions aren't in English or Hindi because obviously, what are the chances that aliens will understand our language? And the bad news is that these instructions have been depicted in the form of diagrams. But why am I saying that it's bad news? Because, just look at this diagram. Forget about the aliens. Take a moment and look at these instructions and diagrams. Can you understand how to operate a phonograph machine? In my opinion, a whopping 90% of the people won't be able to understand these instructions. So how can we expect aliens to understand how to operate this machine by looking at these diagrams? You can see the English translation of these diagrams on the screen to understand what the diagram is supposed to mean. Operating a phonograph isn't very difficult. Aliens will need to understand how to take the disc, place it on the box and place the needle on it. The more difficult task would be to actually see these photos. The photos that you saw, the ones present in this golden record, in 1977, there wasn't any technology that could store images on analog disks in formats like JPEG. Voyager's computer systems could store only 69 kilobytes of data. 69 kilobytes is only 0.07 megabytes. That's not enough for a single image. And to store 115 images within it is unimaginable. That's why NASA came up with a new way to include image data on these disks. They projected these photos on a screen, recorded them with a television camera, and converted the video signals into audio waveforms. And these photos are actually stored in audio form on these disks. So, if the aliens want to see them, they will have to reverse the process for that. The data stored as audio will need to be converted back into an image. How? The instructions are on the interstellar envelope. See if you understand them. This technology is so technical and complicated that the explanation will need a separate video. So, let's move on from decoding it. Let me show you the information contained in Golden Record. Once the 115 pictures are decoded, this will be the first picture. A white calibration circle. A simple black and white drawing that does two things. First, it represents the shape of the record, and it is also a signal that the decoding was done properly. Then they will see the photos of basic mathematical concepts, physical units, quantities, definitions, etc. Then there are two diagrams of the solar system parameters which show the Sun and the 9 planets including Pluto. After this diagram, they will see the individual photos of many objects from our solar system: Mercury, Mars, Earth, and Jupiter. Some images even include explanatory symbols like mathematical definitions or chemical formulas. For example, this photograph titled Egypt, Red Sea, Sinai Peninsula, and the Nile. It also mentions the composition of Earth's atmosphere. The tag above the image shows that nitrogen content in our atmosphere is at 78%. N2 and 78/100ths. It includes some models of chemical elements too, like hydrogen, carbon, nitrogen, oxygen, and phosphorus. These chemical elements represent the fundamental blocks of life. There are two images of the DNA structures, explaining the transmission of genetic information, something that's common in all living beings. This picture shows cells and their division in microscopic details. After this, the next 20 images show human life. Some images show human capabilities too. How our mouth is used for licking, eating, and drinking. Additionally, they included photos of the Great Wall of China and the Taj Mahal. Interestingly, none of the images show the negative aspects of humans. No conflict, world war, or anything akin to war has been mentioned. The images paint a hopeful and positive side of humanity. The ideal version of humanity. As explained by Sagan in his 1978 book, Murmurs of Earth, the Voyager interstellar record. The biggest question here is, will any Voyager spacecraft ever reach an alien? And even if it reaches an alien species, will that alien species have the intelligence level to decode this record or not? What do you think? Let me know in the comments below. For now, the Voyager 1 spacecraft is moving at a speed of 61,198 kilometers per hour. Approximately 25 billion kilometers from Earth. In the depths of interstellar space. Unfortunately, it's not going to function for long. Its power supply is gradually depleting. Scientists estimate that in 2025, its power supply might be entirely depleted. This might sever our communication, but the golden record in it might be preserved forever. Scalar's link is in the description below. And if you like this video, I have made another video on aliens before this. Click and